Hi, today I'm going to show you how to work out the enthalpy change of a reaction when you are given bond enthalpies. So as you can see, this question, they've drawn out the molecules for you so that you can see clearly which bonds have been made and which bonds have been broken. And the enthalpy change of a reaction is given by this particular formula. The enthalpy change is the bonds which have been broken, because you have to break bonds to make new ones, minus the bonds which have been made. And you will always be given a list of bond enthalpies which are always positive. Bond enthalpy is the energy needed to break a bond. And I've just shown you here that because there's a big 2 in front of the oxygen, that means we're breaking double the amount of oxygen bonds and double the amount of the bonds in water. Now I rubbed that out because I realised that there wasn't going to be enough space for me to show my working out. And unfortunately I'm going to have to rub that out as well. And then we're just going to scroll down a little bit and then we're going to start our calculation. With these sort of calculations, it's important to set your work out neatly and do it in a logical order. Messy working out will result in careless mistakes. So I'm breaking 4 CH bonds and I'm breaking 2 oxygen to oxygen double bonds. And then I take away the bonds made. Let's list the bonds made. In carbon dioxide, there are 2 CO bonds. In water, there are 2 OH bonds, but I have 2 water molecules, so it's going to be 2 times 2, which is 4. And then I just use the numbers from the table and put them into my calculation, including all the multiplication. If you want to stop the video here and go ahead and do the calculation, you can do so, and then you can check to see if you get the same answer as me. And we'll see very quickly what happens. Takes a little bit of working out, this does. Okay, so I get, for the bonds broken, I get, 2736, and for the bonds made 3466, and I take them away to work out my enthalpy change of the reaction. And that gives me an answer of minus 730 kilojoules per mole. It's an exothermic reaction, which means that more energy was given out when the bonds were made. So I've just written here, be careful with the ones which have got a number in front of them in the equation. So the oxygens you need to be careful with, and the waters you need to be careful with. This is where the majority of students make their mistake. Okay, the screen has gone blank just for a few seconds because I'm uploading another exam question. And you will see it any minute now. And here it is. Okay, so foolishly, I didn't read the question here and I went straight ahead into doing this. But you will see what happens in a minute. It says, excuse me, use the data in the table and your answer to part A to calculate the enthalpy change for the reaction. I didn't do part A, but I will go back to it, trust me on this, onto part A in just a minute. So what they also haven't done, again they've made it harder for you, they haven't drawn out the molecules for you, so it's going to be more difficult for you to see what type of bonds there are. So my first piece of advice is to draw out the molecules. And then you can see clearly which type of bonds have been made and which type of bonds have been broken. So let's list the bonds broken. We've got 2 hydrogen to hydrogen and 1 bromine to bromine. And I'm putting the numbers in from the table. I'll add them up later. Then the bonds made. I'm making 1 carbon to carbon. I'm making 4 carbon to hydrogen. And then I'm making 2 carbon to bromines. Now let's get the numbers. So the carbon to carbon is 348. The carbon to hydrogen is not listed here. And this is where I need to use the answer from part 1 to answer this question. So what I'm going to do is I'm going to scroll up to part 1. And if you have a look at part 1, it tells you we're looking at methane and it's breaking up into carbon and hydrogen. So this is the energy needed to break 4 C to H bonds. So all I do is I take that number, 1664, divided it by 4 to get 416. So this is the bond enthalpy of a CH bond. And now I'm going to scroll back down again. I'll just rub out a few things. So it's 416 to remember that number. And then I'm just going to add it on to my little table because it wasn't there. So now I can put in 4 times 416 here and 2 times 276, and we're going to do the adding up of these numbers. So again, if you would like to stop the video here and do your calculation and see if it matches up with mine. So the bonds broken is 1065 and the bonds made is 2564. We do a takeaway to find the delta H. And it comes up to minus 1499 kilojoules per mole, an exothermic reaction. So just a little bit more complicated than the one previously. And here is another one. So we are given the bond enthalpies at the very beginning of the question. And what I've done is I've just copied the bond enthalpies from that table and I put them onto the side of the paper just so that we don't have to scroll up and down. So you've got all the information there for you to use. And then I'm going to scroll down to the part of the question where it asks me to work out the enthalpy change of a reaction. So they give me the reaction there, but I can't see clearly which bonds are involved in that. So just as I have done before, I'm going to draw these molecules. So methanol is carbon with 3 CH bonds and an OH. 1.5 O to O, carbon dioxide looks like that, and water looks like that. And I'm going to put a big 2 there. Oh, I'm going to draw it twice actually. Okay, now to put your numbers in. So let's list the bonds broken and the bonds made. I know already that I'm going to run out of space here. So I break 3 CH bonds, I break 1 CO, and I break 1 OH. And I break 1.5 O to O. The bonds made are C to O, 2 of them, and OH, 4 of them. Now we're going to put our numbers in. And I've taken the numbers from the side. And you can do the same. Okay. And then on the other side, 2 times 805 and 4 times 465. Okay, when I do the calculation, delta H equals so my bonds broken comes up to 2781. The bonds made is 3470. And then I need to take away those 2 numbers. And I get minus 689 kilojoules per mole. It's an exothermic reaction because more energy is given out when the bonds are made, or stronger bonds are made than broken. And that's about it. This is the last and final video in my series on energetics, and I've gone through the 4 different types of calculations. Please hit the like button and subscribe to my channel for more interesting videos on A-level chemistry. Thank you very much for watching.